Okay, I think we're ready to start. Everybody here for applied statistics? All right, MA343. This is the way our faculty works here is we teach this on a 2-year rotation. So this is my spring to be up on this class, and this is the smallest number of students I've ever had. We have 11, soon to be 12 enrolled students, and usually it's 25 to 30. So
lucky us.
Yeah, I think it's you computer science people are down in your count a little bit. But that the reason I tell you that is because that's going to make this semester cool, because a smaller group is easier to do fun stuff with, right? And I don't know if you know this, but statistics is fun. It's a lot of fun. I always say that statistics is your favorite class. You just might not know it yet, but you will before the semester's over. Right? Laura thinks it is, because if you had me for MA140, then what we're going to do for the first couple of days of class, today and Friday, is review MA140. If you had somebody else, the questions may be a little bit different, but the material is the same. You don't need to still have your MA140 textbook. The book that we're using in here, this one, contains our entire MA140 book as its first 8 chapters. And we're going to start in chapter 9 and go to chapter 17. All right? It's almost a shame that you have to buy this whole book, because paper-wise, you don't get all of those chapters. 14 through 17 are e-books. They're PDF files that you already have access to. So you only get the paper for 9 through 13, and then from 14 on, you have to go to the other. But that's the deal. Everybody get my email that I sent out about the textbook and the options. And
is there anything I need to do with the first one that you put up that I select a trial on? Or you sent one up, and then you said, go sign up to this, and then you say, don't sign up.
Oh, that was you? Man, you're just too fast. That's something a little bit different than the book itself, but that's the access code. So I'll get to that, but, well, let's go ahead and talk about it. I wrote in the syllabus here, required text as either hard copy or ebook. You have to buy the access code to what they call Launchpad, which is like the software, right? So that contains access to an ebook, so you don't have to have a paper copy of the book. You can get by with the ebook. The problem he's talking about is I first sent out an email with the section ID or whatever, and then the next day I had the rep from the publisher train me on how to use it and say, oh no, don't do that. Don't let them enroll into that one. You need to do a branch course below that, and then let you. So the first one, don't enroll in the first one I sent. Enroll in the second one I sent.
So do I need to cancel that in any way?
No, you just go back in and re-enroll in the new one. You don't need a new code or anything like that. Okay. So there is posted out on D2L, which you can't get to right at the moment because the whole system is down today. But on D2L is instructions for Launchpad or some document like that. Okay? And then that'll tell you how to get enrolled in the section that we're going to do and all that.
When you enroll in the Launchpad thing, does that give you access to the ebook?
Right.
Good.
Yep, the Launchpad contains the ebook as part of it. It's got a lot of other stuff too. There's a lot of resources that are optional. There's some videos out there and some PowerPoint slides and things like that. So use them if you want to. That's up to you. Okay, so I'm going to go ahead and call the roll. I won't call the roll every single day, but I will probably until I learn your names, those of you that I don't already know. So Taylor, I know you, okay, and Josh Christensen. Josh is the reason that I'm recording. He can't. He's the one with the conflict. So Courtney, okay, that's right. You're Courtney, and Laura, and Emily, and Micah Mole, okay, and Corey Pettit. Did I say that right?
Yeah.
Okay. And Todd Rillinger, okay, and Brent West. You had me for 140, right?
Yeah.
I thought so.
20 years ago.
Yeah, it's been a while. And Leanna, the only one left. Okay, good. Anybody I didn't call? Yeah, you.
Jeremy Ellison. I should be in there.
Yeah, you're not on this list, so let me just add you.
I just paid for you.
I believe you, but it'll get worked out. I'll check the roster again. I printed this a couple of days ago, so. And Nate, I just wrote you down.
I'll be on there as soon as detail gets done.
Yeah. Okay, so let's talk about this. Now, let's see if this works. Ooh, I like it. Okay, so I'll let you read the objectives and all that. I forgot to show at the top is my name, Mike Mosier, and contact information and all that stuff. I'm pretty good at answering emails, so questions by email as you're doing things. Feel free to email. If I've already went to bed, then you might not get an answer till the next day. But a lot of times I'm looking at my computer fairly late into the evening, so students tend to use that more these days than office hours. So that's fine. There'll be 5 things you get graded on, all equally weighted. And that's 3 semester exams, then your homework, quizzes, and projects all kind of lumped together. We're going to do probably 3, maybe 4 projects through the semester. Most of those will be group projects. And with a class this small, then that's going to make that easy. We'll probably only have 2, maybe 3 groups that we do. At least one of those projects will be individual, that you have to do all by yourself. Okay? And they're designed, the way I use projects in an upper level class like this is sort of the next step after homework. Homework is, can you do this specific kind of problem? But a project is more, here's a data set. What would you do with this data set to answer this question? And you got to figure it out. It takes longer than regular homework. So they'll be worth more points than a homework, but there's not so many of them. Right? Projects are not eligible for dropping the lowest scores. Your homework, I will let you drop your lowest 2 homework scores. We'll have homework every week. Well, actually, with the Launchpad, it's more than every week. It's about 3 times a week, right? So if you forget to do it a couple of times, then you get to drop those scores. Or if you do it but you don't do very well on it, you can drop it. Once you get past 2, then it starts to affect your grade. Okay? Quizzes. I actually, in this class, I don't tend to do much with quizzes, but I reserve the right, so I put it in the syllabus. Quizzes, I tend to make sort of spur-of-the-moment pop quizzes. They're not announced in advance, and they're like, if I think you're not as prepared as you need to be for a test that's coming up or whatever, I might use it as a scare tactic. And I'll give a pop quiz, and then you look at it and go, ooh, I guess I'm not as ready as I thought, because I had no idea how to do that question. Quizzes aren't worth a lot of points, but once that same question makes it onto an exam, it's worth a lot of points. So it's better to get tested or quizzed on it beforehand. All right. I don't know Launchpad very well. This is the first semester it's ever been available. It's a new product for this publisher, and so there is a quiz capability in there, but I haven't figured out how to use it. So if I do, then maybe I'll do some quizzes in there. But and my plan, if I can figure out how to do it, and she showed me in the training I got the other day, is each homework lesson will have 2, it'll be there twice, and 1 will have the word practice on it. And then I will open up unlimited attempts and all of the helps and all that stuff that are available, And then the one that's for real, okay, now you've practiced, you've got your questions answered, all that kind of stuff. Now go take it for real, and you'll have more limited attempts that you can do, and you can't have it show you how to do it and that kind of stuff. Right? So we'll do it that way. There's also some other things in Launchpad that I'll possibly use, but they're not covered in the syllabus at all. But so grading scale is pretty usual. I don't really need to say much about that. Attendance, just make sure you're here. You won't do well in this class if you don't come to class. If you come to class, it's not going to be that tough. I was telling Nate earlier that this class is not that difficult in terms of how hard the material is to learn, but it is difficult in the time that it takes. This is a fairly time-consuming class. To learn statistics, you got to do statistics, and you got to do it enough to practice, right? And so, if you're not in class and you don't see, the shortcut or whatever, then boy, that can really hurt you. So just make sure you're in class. I said all about the homework, I believe. The projects I've talked about. And those, the first one is coming up real soon. It'll be just in a couple of weeks. And for some of the projects, we'll devote class time to them. So you'll divide up into your groups, and you'll sit and work during class while I'm here to ask questions and wander around. On those days, it might be helpful if you have a laptop that you bring it. Right? We're going to use some statistical software in here. I don't do that in my MA343 classes, but in here we'll do some software. I'm planning to use the SAS software, which SAS stands for Statistical Analysis Software. Right? I used it in regression last semester. Taylor was in there, and I'm embarrassed to say, since then, over the Christmas break, I figured out we had to do coding. Right? We had to actually code a program, and it was kind of a pain because the menu-driven part that I was used to is not in the newer version. Well, it turns out it's a standalone. There is capability, but it's a standalone product you don't access from within SAS. But it goes out and runs SAS on its own, so there is menu-driven. So we're going to go back to doing that. All right? Okay, so I've got two different things that describe the content of the course. This is at a real high level, and then I'll scroll down. There is a day-by-day accounting of what we'll be covering on any single day. I do want to mention on exams, if we have an exam scheduled on a given day, then make sure you're here to take it on that day. Right? I get real bothered by having to do makeup exams, right? My experience in the past is there is a certain percentage of the population, see how I talk like a statistician? A certain segment of the population that use makeup exams because they didn't feel like studying the night before. So they're now, I'm not prepared, so I'm going to call in sick, right? Well, to try to get around that, if you're sick and legitimately sick, I don't want you here making me sick, so please do stay home, but I'll need a doctor's note that says you were sick, right? And hangovers ain't sick, right? That doesn't count. So be here if at all possible. If something prevents you from being here, then that's okay, but I need documentation to allow a makeup test. Without the documentation, then it's a 0. And it's pretty much time to drop the class because a 0 on one of 5 things is probably you're not going to end up with what you need out of this class. Okay? So, here's how it's going to go. We're going to review intro stats. We're going to do that for a couple of days. Then we're going to do chapters 9 and chapter 10 and break for the first exam. So it's going to come real quick. The first exam, just the way it works out, comes pretty quick. Then let me get down to the more detailed part of this. All right, so review for the first 2 days. That's the rest of this week. Jump to 9. go to 10, and then you can see in the syllabus the dates of the exams. Those are tentative. They could move. They're not going to move much, so the exam could be this day or it could be this day. Stop that. Got to be careful not to touch the screen. Okay. But chances are pretty good it's going to be on that day. So you can already start looking ahead if you're going to need to move anything around to make sure that you have the study time you need. Okay? I did move things around a little bit as we come up on exam 2. I typically would put this supplement, analysis of covariance, in with this test, but the way the schedule worked this year, I didn't want the test. If I move this up there, then the exam moves to the first day back after spring break. Students hate that.
I don't know why.
You know, there's two ways of looking at it. You got a whole week to study for the test, but then you don't get a spring break, right? So this gets the test out of the way. You can go have an actual break for a whole week and not have any homework due, nothing to study for this class, and then come back and we start the next section. So that's the way I did it. So you will have an exam the last day before spring break. And even if I don't cover quite as much material as I think I can by then, or I get a little more in or whatever, that's the day that exam's going to be. All right? So if I miss the last section of Chapter 13, then it'll drop onto the next test. All right? Final is comprehensive. And I put on here where it says, for now at least, the final exam is supposed to be. It's supposed to be on Wednesday of finals week at 1:30 in the afternoon. But sometimes the schedules change a little bit as administration figures out, oh, there's conflicts or whatever. So we'll keep track of that as we get close. I do want to point this out. The last 2 weeks, so week 15 and week 16, week 15, there's no new material. So this exam 3, there's no new material taught after that. And then it's work on the last project. And the last project will be fairly labor intensive. Right? It's going to take you a while to do. But by Friday of that week, you need to be prepared to give a presentation, an oral presentation to the class on your project. Now this will be a group project, so there'll be 2 or 3 of you together doing the presentation. Right? And depends on how many groups we have, whether we need 2 days to do that or 1 day. But this last week I always reserve for reviewing for the final. So if we need to use a day of those 3 days for group presentations, we will. But if not, then we'll get all 3 days to do review. Okay? Any questions about the syllabus? Or the way the class is going to work? All right. Good. So let's...
Are you going to be using D12 for grades this semester, or are you still...
That's a good question. I don't know. There will be some place where you can always have access to your grade. I've never learned how to use the D2L grade book. Launchpad probably has a grade book in it. And I usually find that the one that is in the homework system is easier for me because I don't have to, because it's keeping track of most of the grades that you have, all those homework grades, and I don't have to transfer all of those into D2L. It's easier to transfer a few tests into there than it is, 25 homeworks into the other. So, but one way or the other, you'll have access to a grade book, right? Okay, any other questions before we launch into our MA343 review? All right, so let's do that. Now, the one thing I was hoping, but I don't think it is the case, I was hoping that when I pull up a Word document or something that I could write over the top of it, but I can't. The only thing I can write in is that this software. So a lot of the time I'll be like that. Yeah. A lot of the time I'll be writing into this thing, which is nice, I think. I've never used it, but is I can scroll to the next page and the next page or whatever and then save it. And then if you say, hey, I didn't get good notes on that whatever, I can send you those.
You should be able to write on it if you click Word and then where it is on the side. Click
Do what now?
like if yeah.
Over here?
Yeah, click on the pen.
The top.
You should be able to write on it.
The cog next to it. Is there in settings somewhere?
Maybe. Object transparency. Maybe we make it a little more transparent. Enabling to fade after you write it. I don't know what that means. I don't know, but if you've seen other people do
Yeah,
it.
we did it in my Woo class, and that's how she got it to work.
Okay, well, I will try to figure it out. There's two different software packages that go with the smartboard, and somebody told me that this is the one they like. It's called Active Inspired, and the other one's a smartboard or whatever. So maybe it has that capability, and this one doesn't or something. But anyway, so since I can't do that at least today, what I will do is I'll work over there off of this as needed if we need to do that. But what I've done here, and this worksheet is out there on D2L. I'm pretty sure I've already put it there. But if you go looking for it, and all semester long, I'll just say this. If you go looking for something that I told you would be there, and it's not, that means I forgot. So just send me an email and remind me. Hey, you forgot to put this up. Whatever, right? Notice that number 1 here is highlighted in yellow. And then as we go down, there'll be others that are highlighted in yellow. Those, I'm not going to work in class, and you have to work them and turn them in as a homework assignment. The rest of them, we'll do some of them, and we won't have time to do all of them. Because what I did is I just took and if you had me for MA343, you may recognize these, but this is MA343 reviews for the 3 exams, right? So it pretty well covers the whole semester in these. So you'll see review exam 1, and then like the 5th page down, it'll say review exam 2, and so on, right? So I picked a few of those off of each one to be the required ones that I will grade. The rest of them, you should look through them. I'll post the key to the whole thing after we get it done. We'll work some of these in class. We'll talk about them. But by the time we get through this whole worksheet, you should at least refresh your memory on, oh yeah, I remember doing that. Right? I remember what a confidence interval is and a hypothesis test or whatever. Okay? So this first one, which is required for you to do, is a definition kind of one. And some of those I used. Most of the ones that are highlighted are ones where you have to actually work something. But this is, what is it called when you draw conclusions about a population based on a sample? You may have to look that up to remember. Right? What's the difference between a parameter and a statistic?
Parameter is all the whole population, and statistic is a sample within the population.
Good. A parameter refers to a characteristic of the entire population, like the mean, right? The mean height of everybody in the whole population, that would be called a parameter. And in statistics, what kinds of symbols do we use for parameters?
Numbers.
No. Greek letters, that's right. So in statistics, the common, it's not, there are exceptions, but if you see a Greek letter, like a mu or a sigma or an alpha or something like that, they're referring to a population parameter that is unknown and unobservable. So then you have to draw a sample from the population and estimate that parameter. So the estimates are called statistics. Parameters refer to the whole population. Statistics refer to samples. So this is which following is most likely a parameter rather than a statistic, you're looking for one of those that's talking about all members of the population. The rest of them will talk about some sample from a population. So the first one says average time it takes for the first 5 students to complete a statistics exam. That's a statistic because it's a sample from all of statistics, the first 5 of them. Right? Average age of males selected at random. That's a sample. Average height of NASCAR Nextel Cup Series drivers during the 2005 season. That's the parameter, right? Because that's all of them. It's saying the average height of all of those drivers. And so it's a limited population. In practice, I said a minute ago that parameters were typically unobservable because it's not possible to measure the entire population. But if you have a really small population, like the population of all students who took MA344 in the spring of 2016, I got a population of 12 people. I can measure everybody. But generally, in practice, the population is huge. You can't measure them all, so you draw samples. All right? This one is a statistic. Goes right along with that. Summary statistics from populations and from samples. Number 4 talks about weights of, is it all humans or males? Weights of adult males have a mean of 173 pounds and a standard deviation of 30 pounds. Suppose the distribution is skewed to the left. What does that mean, skewed to the left?
That means the tail goes really far left.
Right. So, I'm going to get into this. How do I erase? Right there. Okay, so skewed to the left would be like that, right? The direction of the skew is which direction the long tail points. So what the heck did I just draw? I drew a distribution. What does the height of it indicate?
That more men weigh more.
The height indicates how many men are at that weight. So you think of this axis being the weight axis, the x-axis, and you're dividing into sub-intervals, and maybe they're by 10 pounds or something like that, right? So down here is maybe 100 pounds, and this is 110 pounds. So in here, think of drawing a bar, like a histogram. They're saying, well, you don't have very many men that are adult men that weigh in that range. So a very low bar. But out here, maybe at 170 pounds, whatever you think average, what did it say, 173? Right? That's where a tall bar is, right? So basically think of a smooth curve for a distribution as being a histogram, a bar chart, but the intervals have gotten so narrow that they go to 0, so it's a continuous distribution, right? Okay, now back to the question. The question said that the mean was 173, and the standard deviation was 30, skewed to the left. Which of the following values is most likely the value of the median weight? So this is saying, this is testing whether you remember what happens to the mean and the median in a skewed distribution. The mean gets pulled into the long tail, right? The mean is more affected by outliers than the median is. So the outliers in a skewed distribution are in the long tail, right? So the mean's going to get pulled down. The median's going to stay more where the hump is, right? So the hump is out here, about right here. So where would the mean be? That way. So the mean, oops. The mean might be there at 173. So the median is going to be closer to where the hump is. So the median is going to be bigger than the mean. So we go back to the question. Which one is most likely the median? There's only one of those that's bigger than 173. So that's the right answer. Now, I've never bothered to go back and fix this because this is just a review, but a lot of people would select E on this one. Not enough information to determine, and you're right, there's not enough information to determine that it's exactly 188, but the point is, it's a number that's going to be bigger than 173. So that's the only number. So I should scratch E out of there and make you choose a number. Right? Okay, correlation and regression lines. Remember about those? What kind of data are you dealing with if you have a correlation and regression kind of problem? How do I add a page?
Right underneath the insert tools. At the top bar.
Ha! That was easy. Thank you.
You're talking about scatter plot.
Okay, so you're talking about scatter plot, right? So if you have a linear regression and a linear correlation type problem, you're talking about data that has an x variable and a y variable and a scatter plot. I like that. Right? So what is correlation? What does correlation mean?
Value between
Sense a pattern.
-1 and 1.
Okay, it's a value between -1 and 1. And would this be positive or negative? Positive because it goes up to the right. If it slopes down, it's a negative correlation. Then the limits are -1 and 1. So if you get out to either of those two extremes, what's a correlation of 1 tell you? It's a perfect linear relationship. So the points fall exactly on a line. Right? That would be a correlation of 1. Correlation of -1 is perfectly on a line going in a negative direction. So what's 0 correlation?
No pattern.
No correlation at all. No relationship between x and y. All right? So this picture that I drew is definitely not perfect correlation, but it's certainly not 0 either. What would 0 look like? Random all over the place. I say a shotgun blast. Right? It looks just... It can be a circle or it can be... Here's 0 correlation. Right? Well, that's not a shotgun blast. That looks like a pretty well-defined line. But the problem is it's a horizontal line. Remember that correlation measures how much y depends on x. Here, y doesn't depend on x because as x gets bigger, y is not changing. So y doesn't depend on x. So 0 correlation. Okay? Even if they're perfectly on a horizontal line, that's 0 correlation. But as soon as you tilt that line a little bit, now it's perfect correlation. So it's kind of tricky that way. Okay, so that's correlation. So I forgot what the question was. The correlation and regression line are non-resistant, unrelated, causal, resistant, non-resistant, and resistant. That means affected by outliers. So resistant to outliers or not resistant to outliers. The mean and median we talked about a minute ago. The mean is not resistant to outliers. The median is resistant to outliers. What do you think about correlation and regression?
Not resistant.
Not resistant. Why not?
Because you're adding in an outlier and then you're computing the data and that's going to skew the line
Okay.
towards the outlier.
That's right. That's true. Let me draw a picture. Those are all, that's supposed to be a perfect grid, but I kind of got a little accidental slope there on the top. But what's the correlation there? You shook your head no, Brent. What do you mean? It is 0. This is 0 correlation, right? It's It's set out in a grid pattern, but zero correlation. Now, what if I add a point right there?
That's like 0.9.
Now I got a really strong correlation because these are all tightly clustered around a line that would go, right? So one point can really influence the correlation coefficient. So it is not resistant to outliers. This would definitely be called an outlier. It's an outlier by definition is a point that is a long ways away from most of the data. So as soon as we get to chapter 10, we're going to be getting back to linear regression, which you've had a chapter on in MA343, but we're going to get more detail and learn about statistical inference and confidence intervals for the slope and for the intercept and all that stuff. Well, outliers can really affect that inference. So, which of these statements is true? So you'll need to read those. But you should have heard me say some things like this if you had me for MA340. But okay, what about a correlation coefficient of 0.37? Weak, positive. That's right. This would be A. That is, 0.37 is positive because there's no negative sign, but it's weak. 0.37 isn't very strong. Right? Now, there's no real definite rule of thumb about what is strong, weak, moderate correlation, but I generally say that if it's below 0.4, then it's weak to none, right? Because just random scatter, if there's a couple of points that make it look like, yeah, there could be some slope there, you'll get a correlation of 0.3 out of that, right? So that's pretty non-existent. The blank is the outcome variable on which comparisons are made. The outcome variable on which comparisons are made. I don't like the way that's worded particularly. It's a little confusing, but that's the response variable, right? Remember, you have an explanatory variable and you have a response variable. The explanatory variable is usually x in a scatter plot, and you're using it to try to predict what the y variable would be. So it's also known as a predictor variable. So predictor variable, explanatory variable are the same thing, and then it responds to that. Well, the response is what you're going to compare. Are females different than males in their response? Okay. What's a lurking variable? That's one of the options there. Remember that definition?
Is that a variable that doesn't matter?
No, it
it's
certainly
the one.
doesn't matter.
It comes up when you don't expect it.
That's right. And the name lurking, right? I love that term, a lurking variable. I just like to say lurking. What does that mean, lurking? Sneaking around. I think of the Addams family. Lurking. But it's a variable that can influence the relationship that you are interested in. And technically, that term lurking variable means it was not collected in the data and the researchers didn't think about that variable, as opposed to a confounding variable, which is collected. So if it's collected, you can go back and reanalyze the data and account for that variable. So it's a subtle difference. I won't make you know the difference in those two terms, lurking versus confounding. But just know that a lurking variable can either hide a real relationship or it can make a relationship appear to be there when there isn't. Right?
I can't remember what the difference is with the hidden and lurking variable.
They're probably referring to the same thing, right? Here's a good example. You can look up data and find that there is a very strong association between months of the year, or looking across months of the year. There's really strong correlation between beer sales and ice cream sales. Right? Now, does that mean that drinking beer makes people crave ice cream? Or vice versa?
Maybe they have that new root beer or something.
Or could there be a third variable that's not being accounted for that explains both of them changing from month to month? What might that be? Temperature outside. Right. So in January, you don't sell as much ice cream. And you don't sell as much beer. Right? Although beer sales are less affected by temperature than ice cream sales. But there still is actually a pattern there. Right? So you would be wrong to say that, wow, there's an association between consumption of beer and consumption of ice cream. It's because there's a third variable that's acting on both of those. And that's called a lurking variable. Right? So that doesn't fit. We're not making comparisons on the lurking variable. We're making it on the response variable. What's that? Okay. Okay. Now this one is one that I've highlighted. So I'm not going to work this one for you, but I'm going to give you a little reminder about how you work a problem like this. So let's read it. In human engineering and product design, it's important to consider the weights of people so airplanes don't crash. Right? Based on data from the National Health Survey, the weight for adult males follows a bell-shaped distribution with a mean weight of 173, standard deviation of 30. Now that sounds like the same problem we had before, only it said it was skewed left. Now it's saying it's just because I want to ask you a different question. But this is more actual. Weights are normally distributed. So first of all, what does that mean, normally distributed? Or bell-shaped distribution? Okay. The median and the mean would be about the same. It's a symmetric distribution, and it's shaped like a bell. That's what bell-shaped means. Right? So this is what I call an empirical rule problem. I think I remember hearing about empirical rule at some point. So let's do that. Okay, so empirical rule, remember how the standard deviation applies to populations and samples, right? So here's a nice bell-shaped distribution. Somewhere in here, there's probably a tool to just have it give you one that's perfect. I haven't figured that out yet. They told us that this thing is mean of 173. Right? In a symmetric distribution, the mean will be right in the middle. So mean of 173. Now, how does the standard deviation come into play? What does that term even mean? Standard deviation.
All data is within like 64%.
Okay, that's empirical rule. So that's where we're going. But before we get to there, what is standard deviation? You know, if you can't remember what something is, try to break it down using English, what you learned in English. What does the word standard mean? Normal or typical or, right? Average. The standard. So what does the word deviation mean? Okay, to deviate from means to be away from, right, what's normal. What did you say?
How much it is away from the normal or the average.
Okay. So the standard amount of deviation from this mean. That's what we mean by standard deviation, right? And it said it's 30 pounds. So the standard amount of deviation is 30 pounds on each side of that. So that's to 203 and to 143, right? So if that's the standard amount of deviation, then I would expect that it would not surprise me at all to find an adult male who weighed 143 pounds. And it would not surprise me at all to find an adult male that weighed 203. Right? The empirical rule tells us what percent of the population would fall in nice integer multiples of the standard deviation. So, anybody remember where one standard deviation falls? Okay, you're ahead of me on empirical rule, but what did you say?
Halfway up the curve.
Okay, about halfway up the hill or down the hill in each direction is one standard deviation in a normal bell-shaped distribution. So this is going to be 203, and this is going to be 143. And you said, Emily, that in between those two dotted lines would be 68% of the population. Now this is approximation, right? It's about 68%. It's not exactly 68%. No distribution is perfectly exactly normal, right? But if it was, then 68% would fall within plus and minus 1 standard deviation. Right? So the empirical rule says that mu plus and minus sigma. Ooh, another Greek letter. 2 Greek letters. What is mu? That's the mean of the population. So that's the mean of the population, and sigma is the standard deviation of the population. Right? Down here on scratch paper, x with a bar over it is the sample mean. Mu is the population mean. Sigma is the population standard deviation. What's the symbol we use for sample standard deviation? S. And sometimes we'll put a subscript of a 1 on it or a 2 on it if we have 2 samples. Or we might put a... Started to use my finger to erase like I'm normally would on a whiteboard. I still tried to do it. There's a little delay I got to get used to. So S, we'll put a subscript of the variable. So if my variable is x, I'll say S sub x, the standard deviation of x. I might have 4 variables. X, Y, Z, whatever. S sub whatever variable. Right? So the notation we try to keep so it's kind of self-explanatory. But so anyway, mu plus or minus sigma should give you 68% of the population. Now, if that's 30 pounds, that distance is 30 pounds. If I go another 30 pounds, I'm right there. And right there. So what percent should fall in there? 95. 95% is within 2. So mu plus minus 2 sigma is 95%. Right? So what it says is 95% of the population should be within 2 standard deviations of the mean. So if I go another 30 below 143, I'm at... No. I'm not ready. I'm just... What's the number that goes here? This is 143 pounds. Subtract 30, you get 113. Right? And then add another 30, you get 233. Right? So 95% of adult males will be between 113 pounds and 233 pounds. That sounds about right. Now, if we go one more standard deviation, mu plus or minus 3 sigma. Anybody remember that number? 99.7%. Right? Or as we say in Kansas, pert near everybody. That is 99.7%. So in other words, it's very, very rare to find somebody that's more than 3 standard deviations away from the mean in any normal bell-shaped distribution. Okay? So very rare. So another below 113, you can think, yeah, I don't know many adult males that would be that light. Right? What's that, 83 pounds? Okay. Even I weighed more than 83 pounds when I was a freshman in high school. I weighed 90 pounds as a freshman in high school. I was 4'10", what they call a late bloomer. But boy, did I bloom. No, just kidding. So let me finish this diagram. That would be 99.7 down to 83 and up to 263. Okay? Now, let's go back to the question you were asked. The question you were asked said, what proportion of the weights is between 203 and 263? Okay, now what? 203 and 263. So that's shade this region. What's the area of that shaded region? All right? So you can do it now. You can know the empirical rule. They ask proportion, not percent, but I don't care about that. But so change these to 0.68, 0.95, 0.997. You can use addition and subtraction to figure out what that area is going to be. Right? And we are out of time. So we'll pick up there next time. Well, there is one more thing in this one that I want to do. I'm requiring you to do one, here it is, on linear regression, but you may need some refreshing on how do you get that out of your calculator kind of thing. So I'll give you some hints there. All right, we'll see you Friday.